So the formula for this works in this way. So first of all, we want to find, we're going to use a point slope formula again, and we're going to make a linear approximation. Okay, so this is our first point here. Okay, and we're going to use a linear approximation using that coordinate. Okay, so this coordinate here is going to be our first iteration and the y value for that first iteration. Okay, so there's our points here. That's our initial point. Okay, and basically what we're trying to do is solve for this second point here. Now that second point has a known y coordinate because that point right there, the y is equal to 0. So what we're going to do then is let the y equal to 0 and rearrange the green part. So the y, that y2 here basically disappears. And if we rearrange this green part here to solve for x2, we get this as formula here. And basically this represents a closer approximation to the root than the first approximation. So that's our first approximation. We calculate the y value for that first approximation and we divide by the slope at that point. Now because of this rearrangement, that will calculate that next approximation, or x2. Now because we can reapply this, we just basically then, we can generalize this. Instead of just saying 1 to 2, we can say n to n plus 1. Okay, this should be n here and n here. Okay, so we're going to plug in the n values into the y value, the function, and we're going to calculate the xn value of the slope at that point, and using that we're going to be able to get the next iteration, or the next 0, based on this rearrangement that we've got up here. So this is a recursive formula that we can use to solve or approximate the 0 for any number of iterations. And the more iterations, the closer you get to the actual solution. Okay, so let's try this one here. Okay, so let's approximate the square root of 2 to 3 decimals. To do that, we're basically going to solve this equation. Okay, x equals square root 2. Okay, we're going to solve it, just make it x squared equals 2. And then we're going to use this function, x squared minus 2, y equals x squared minus 2, to approximate it. So basically what we're going to have here then is, okay, here is our graph, and this point here should represent, at y equals 0, that should represent square root 2. Okay, so what we're going to do then is we know that it's pretty close to 1.5. So we're going to use our x1 as 1.5. But before we do that, we need to calculate our f prime. So that's what we'll do here. We'll calculate f prime of x. Okay, f prime basically is 2x. Okay, we're going to choose this x1 as 1.5. So let's choose, I'm just going to exaggerate it, it's 1.5 about here. So we're going to find that coordinate, and we're going to use that line to approximate that next point. Okay, then that point represents our x2. So let's apply the formula here. It's going to look like this. Okay, it's going to be our x1. Let's do this in black. So x2 is equal to 1.5 minus f of, I'm going to do this in red, or sorry, I'm going to do this in black, f of 1.5 over f prime of 1.5. Okay, so that's going to be 1.5 minus f of 1.5 is 1.5 squared minus 2 over 2 times 1.5. Okay, so our first iteration is going to be equal to 1.5 minus, this is 2.25 minus 2, or 0.25 over 3. Okay, so that's going to be 1/12. Let's punch that in our calculator and we can get our next iteration here. Okay, so it's going to be 1.5 minus 0.25 divided by 3, okay, which is 1.146 repeating. Okay, so this is going to be 1.1416 repeating, which already after our first iteration is pretty close, because basically the square root of 2 is 1.41. So we can reapply this to get whatever accuracy we want. Okay, so I'm just going to set this up in my calculator, and I can do this one more time. So I'm going to do x3. Okay, x3 is going to be equal to 1.416 repeating minus 1.416 repeating squared minus 2 over 2 times 1.416 repeating. Okay, so I'm going to I've got my graphing calculator, which allows me to just plug in an answer value, and then I can just reiterate. I could just iterate this solution as many times as I want. Okay, very, very easily by just kind of getting the calculator to do all the calculations for me. Okay, 2 times. Okay, so the next iteration works out to be 1.41174 dot 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 dot. Okay, and then I can use that same value, that exact value, and do it again, and I get 1.66. Okay, it's not quite 6 repeating, okay, but again, we're getting closer and closer, and the more times I do this, the closer and closer to I'll get to the actual value of square root of 2. Okay, so that's how Newton's method works. So we'll do this one here. We'll do it again. So we're going to set this up so that we make it equal to 0. Okay, because this Newton's method is basically allowing us to get to 0. So there's my equation. Okay, so I'm going to write it as a y equals. My y prime value works out to be e to the x minus 2x. Okay, so I'm going to set up my x n plus 1 is equal to xn minus f of xn, so it's going to be e to the xn minus 2xn over, sorry, that's going to be e to the xn squared. Okay, so this is f of x on top. Okay, e to the xn minus 2 times xn. Okay, that's going to be my derivative on bottom. Okay, so f of x divided by f prime. And applying this formula, then I can just calculate the first iteration. So I'm going to go say, I'm just going to estimate probably 1. 1's not a great estimate, but let's say 1. I'm going to use x equals 1 as my x1. So x1 equals 1. Okay, so then I can say x2 is equal to 1 minus e to the 1 minus 1 squared over e to the 1 minus 2 times 1. Okay, so let's calculate that. That's going to be okay, so I'm just punching this into my calculator right now. Okay, so my first iteration is going to be negative. Ooh, looks like I'm going to get a negative here. Okay, so I get negative negative 1.39, etc. Okay, Now, what I want to do is I'm just going to reapply this. I've got this set with my calculator, so to get 2 decimals of accuracy, I just kind of keep reapplying this. And I do once, twice, 3. After my 4th time, I've got my second decimal of accuracy. Okay, now you don't necessarily want to do this over and over by hand. Okay, so you want to be able to set it up in a calculator so that you can just kind of get the calculator to do the work. But I need to, if I apply this 4 times, so x3, my x3 value works out to be negative 0.835, I think it is. Dot, 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 dot. My x4 works out to be negative 0.7098, dot, 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 dot. Okay, my x5 is negative 0.703, dot, 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 dot. And that's pretty close. So if my next, actually I should write down my next, because I've got actually the next value here. So I'll show you how accurate it is. Once it starts focusing in, it gets very, very accurate. Okay, so dot, 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 dot. Okay, so this is good enough. This means I have 2 decimals of accuracy at least, okay, because that second digit doesn't change. But even after the next one, I actually have quite a bit more digits of accuracy. It goes 7346, dot, 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 dot. So I've gained 2 more digits of accuracy in the next iteration. So it's getting very, very accurate very quick.